this next example here is gonna be a combined version, and it's gonna be a little more challenging here. We're still finding domain, but the function is gonna grow more challenging. So find the domain. The function that we have, f of x equals to square root of x minus 3 and all over x squared minus 16. And here in this functions, I have a combination of the two concerns together. I do have a square root, and I do have a fractions. And here x squared minus 16 is my denominator of the fraction. So now I need to look for the domain that appropriate for the two concerns here all together, and then blend the two domains together to find the finalized version of the domain. So first of all, let's worry about the fraction nature. Now for the fraction nature, remember the requirement here is the denominator cannot be equal to 0. So now to spot out all the bad values of x that cause the denominator to be equal to 0, you need to set the denominator equal 0 and solve for x. So in this problem, once again, you have a good number of ways how to solve this equation. Now, like in one of the similar example we had earlier, you can add the 16 to the other side and take the square root on both sides. Here I'm going to try a different approach here this time. We can do, I recognize this x squared minus 16 as a difference of two squares, so I can do x minus 4 and x plus 4, and that's how we can factor the difference of two squares. And so now using the product principle, the zero product principle, you can solve for x by setting x equals 4 and the other x equals negative 4. So these values for x will cause the denominator x squared minus 16 to be equal to 0. So these are the bad values in the functions. So we need to exclude. So first of all, I know that the domain, clue number one is the domain need to be exclude 4 and negative 4. But now keep in mind, in this problem, this is not all the domain going to be, because the domain has to also somehow involve with square root. So now I need to take care of the other piece of problem. So the other clue of the function here is, now we have square root, and square root, the quantity under the square root needs to be non-negative. So I'm going to have to set x minus 3 greater than or equal to 0. Or like I said, the quantity underneath the square root cannot be negative, meaning that quantity has to be greater than or equal to 0. And now I'm going to need to find the x value that causes the quantity to be greater than or equal to 0. And to find that, I'm going to solve this inequality. And so adding 3 to both sides of the inequality, that gives me x greater than or equals to 3. And so now those x values greater than or equals 3 is going to satisfy the quantity underneath the square root greater than or equal to 0. So this is also another part of the domain. So now I need to bring the two little clues here together. Here's I have one clue, and here's another clue. We need to combine the two clues here together to find the combined version of the domain. And so now it's always best to bring all that ideas into the graph. And so I have a negative 4, I have a positive 4, and I have a 3 somewhere here in between negative 4 and 4. And so now this function is saying I do not want negative 4 as the way how it says right here, any x value but except negative 4 and 4. So I'm going to exclude negative 4. I am going to exclude 4 as well, and I'm going to take supposedly anywhere else. But now together with this second conditions in the bottom right here, I need to shade anywhere from 3 and above. So here I can only shade this area. And once again, keep in mind, we're still excluding 4. So that means my interval this time, once again, the reason being I cannot shade the part out here because it's less than 3, and that's violating with the second conditions. So you need to, once again, you need to shade in properly that fits with the two requirements here. And so now here I'm still using brackets on 3. And so the visual display now is making it clear to write the domain in interval notation. So now what I have is, first I'm going to have that little shading portion right here, 3, 4, brackets on 3, parentheses on 4, because we're excluding 4. And then I have another interval from 4 to positive infinity. And here I'm using parentheses on both sides. And now we take a union of these two. And there is your domain in interval notation. And so once again, this is the domain in interval notation for the function square root of x minus 3 all over x squared minus 16. And then in a next example, example number 9, if you want to find the domain of, let's say we want to find the domain of the function f of x equals 1 over the square root of 45 minus 15x. And so now once again, you have the two concerns here all together in this problem. Out of all the two concerns, you have them all in this function. I have a fractions, and where my denominator is the entire square root 45 minus 15x. So all that square roots and together with 45 minus 15x is my denominator. So I need to, once again, as you can recognize, the pattern of work here is you always, when you run into fractions, you ought to always take the denominator of the fractions, the whole denominator, and set it equal to 0. Why are we doing that? Once again, we need to find all the values, all the bad values that cause the denominator to be equal to 0. And now, to solve this equation, we have had back in 1.6 we had problems. We learned how to solve square root equation like this. So now I need to square both sides, and that gives me 45 minus 15x equals 0 squared, which is namely 0. And then here, so I have 45 minus 15x equals 0. And now solving for x, I'm gonna have to subtract 45 from both sides, and that gives me minus 15x equals negative 45. And here, dividing both sides by negative 15, that gives me x equals positive 3. So, and once again, here we are not done. This answer is not our domain. It's not the answer to our domain problem. But we know for sure the domain must exclude this value. The domain must exclude this value. So now, so the first logic here is, the first implication here is the domain is going to be any x except 3. And that's one logic. And we might put that as a condition number 1 right here for the domain. Now, to find the condition number 2, let's go back to that. And once again, the other concern here we have is a square root. So now my square root here, I have a square root in the denominator. And so look at the square root. The quantity underneath the square root cannot be negative, meaning the quantity 45 minus 15x must be greater than or equals 0. So now I have set up for myself an inequality. Now I need to solve for x. I need to find those x values that cause the quantity 45 minus 15x greater than or equal to 0. And to solve that, I'm going to subtract 45 from both sides once again. And here I have minus 15x greater than or equals minus 45. And now I need to divide both sides by negative 15. I'm sorry. But now dividing by both sides of that inequality by a negative number is going to cause the inequality to switch in sign. So here I have x less than or equals to 3. So I have x less than or equals to 3. And so now that is my condition number 2. I need in my domain, I have to also know that I can only choose x less than or equal to 3. So now bringing the two conditions together in a line, here's how it works. In your line of number, 3 is right here. From condition number 1, you know that you're going to have to exclude 3. So that's how it works. In condition number 2, you know that you're only going to shade to the left side of 3. And even though condition number 2 says that you're including 3, but since condition 1 says we're excluding 3, so now the shading here is going to be excluding 3. So that's how you bring the two conditions together into the graph. And now the graph is making it clear that the domain for this function, finally, the domain for this problem in interval notations is going to be minus infinity to 3 in parentheses. And that's how we find the domain of those functions. 1 over square root of quantity 45 minus 15x.